we're going to talk about factoring by groups. Factoring by groups. Or factor by grouping, either one. If you have more than 3 terms, you do not have a trinomial, but has more than 3 terms, you can try to factor by grouping. Put the terms that you have together and see if those terms factor. And if they don't factor, maybe you could rearrange them a little bit and see if that factors. But you can factor by grouping. Let me show you an example. So we've got 6y cubed minus 21y squared minus 4y plus 14. So I have 4 terms there. That's not a trinomial. I can't do my x factor because I have 4 terms, but I can factor by grouping. I can put my first set, separate my second set. I can factor those 2 groups together. What can I take out of this first group? 3y squared. If I divide this by 3y squared, what's left? 2y. If I divide this by 3y squared, what's left? Is there anything that can come out of this group here? Okay, can I maybe take out a negative 2? What's left right there? 2y minus 7. And look, we have our matching groups. So we have 3y squared minus 2 times 2y minus 7. Think about it, factoring by grouping is pretty good because you don't have to, you just group. You don't have to do, okay, what will multiply give me this and add, it takes out the part where you have to find b. So it actually takes a step away. Alright, try this one. A squared plus 10ab plus 25b squared ax plus 4bx. There you go. Try that one. Put the first 2 together. Put the first 2 together. What can I take out? 2x. All right, great. And I'm left with. All right. Second group. What can I take out? negative 3y, and I'm left with plus 2b. Right. So I have 2x minus 3y times a plus 2b. Right? Okay, now let's talk about a perfect square trinomial. And then after we talk about a perfect square trinomial, we'll go back to that other one that I showed you. Alright. A perfect square trinomial is a problem that started out like this. That's how a perfect square trinomial started out. When you boil this out, remember, that is not a squared plus b squared. You don't distribute that exponent through there, okay? When you boil that out, you get a squared 2ab b squared. This one, you get a squared minus 2ab plus b squared. This is actually a perfect square trinomial. Now, if you didn't recognize that that was a perfect square trinomial, you wouldn't be sunk, okay? You wouldn't just be like, oh, I can't work this out. It's pretty easy to think of two numbers that multiply to equal 100 and add to be 20, right? What are they? 10 and 10. See how you're getting the same number? That should give you a hint. Oh, wait, it's a perfect square trinomial. A has a square root. What's the square root on this one? 2x. What's the square root on C? And what's 2 times 2x times 5? 20x. That tells you, hey, this is a perfect square trinomial. You can factor it out the long way if you want with your x, but it's going to factor down to 2x plus 5 squared. It's going to end up being 2x plus 5 times 2x plus 5 because it's a perfect square trinomial. Just a way to save you some time. If you can recognize these perfect square trinomials, it will save you so much time. Do you have that written down? Right, your first hint, when you look at A and you look at C, and they're both perfect squares. What's the square root on this one? What's the square root on this one? Alright, just check. What's 2 times 2x times 3? 12x. Okay, this is the perfect square trinomial. It's going, now this one has a minus sign, so it's going to factor down to 2x minus 3 squared. If maybe you missed out, like, oh, I didn't notice that, and you had to find two numbers that multiplied to give you 36 and added to give you negative 12, it's going to be negative 6 and negative 6. That should be, oh, it's a perfect square trinomial, and I didn't even notice, right? Okay, so let's go back and look at that other problem that I tried to give you on accident. A squared plus 10ab plus 25 b squared minus c squared. 4 terms. I have to factor by grouping, right? But hold up. Wait a minute. Look at just those first three terms right here. Is that a perfect square?
Yes.
Is that a perfect square? Is this 2 times A times 5B?
Yes.
All right, let's group it right here and leave that little fella out for a minute. Okay? Factor the front end. It's a perfect square trinomial. So what is it going to factor to? A plus 5B quantity squared minus C squared. Right? Yeah? Yeah? Okay, this is where it gets so much fun. I love this. Because you think you're done, but guess what? You're not done. Right? Because what's that? And what's that? And what's that? A difference. What do you have now? It's a difference of 2 squares. So you thought you were finished, but you're not. Because math is ego. You're not finished. This factors again because it's a difference of 2 squares. This factors down to A plus 5B minus C, A plus 5B plus C. Now you're finished. That's your final answer. All part of our evil plan for mathematicians. Alright, I'm going to give you one of those tricky ones to do by yourself, okay? Squared plus 4x plus 1. And it's very much like the one we just did together. On the front end, we have a perfect square trinomial. Two x, 1, 2 times 2x times 1. So this factors down to 2x plus 1 squared minus y squared. Now I have the difference of 2 squares. Square, square, difference. It's the difference of 2 squares. So it's the first one minus the second one, the first one, plus the second one.
Where did the extra, or the 2 times 2x times 1, where did the other 2 come from?
Here?
Yeah.
Because this is A, this is B, this will be 2AB. Remember? See now? That's how we're checking it. This has to have a square root, that has to have a square root, and this has to be 2 times the first square root and the second square root. The middle one does.